Well, hello guys, welcome back to Mr. G Physics. This is Mr. G, and this time we're going to be doing another video related to forces. Today we're going to learn about normal forces, another type of force. Now, in the previous video, we learned about gravitational force, or weight. Remember, it was the force the Earth exerts on objects that are near the surface. So let's quickly recall. We have a table, for instance, on the surface. Remember, this one is the Earth. Alright, so what is going to happen? The Earth is going to pull towards its center that box, block, whatever the object is. Alright, so on this object there will be a force acting towards the center of the Earth, which we call weight. This one is weight, or you can call it gravitational force, and it's alright. It's not a problem. Alright, remember also that, just to recall, that weight can be calculated by the product of mass and acceleration due to gravity. And if we're working on the Earth, then G is approximately 9.8 meters per second square towards the center of the Earth. I'm going to write down, but remember it's towards the center of the Earth. So all this one was done before, was done in a previous video. Now my question is, why does the box don't move actually or go towards the center of the Earth? Well, that's correct. You are right, absolutely right. There is a table. The table is preventing that box to go to the floor. But even though if it was on the floor, still cannot go to the center of the Earth. For instance, if we remove the table and the box is out of the table, there's still going to be a force that the Earth is going to exert on that box towards the center of the Earth, which is weight. But why does the box don't be taken in the surface of this? Well, yes, you are correct. There is the Earth. This is the surface of the Earth. Now that surface of the Earth and that table are applying a force on that blocks to prevent the block to go towards the center of the Earth. That force is called a normal force. So normal force is that force that the surface or a surface apply or exert on objects that are on the surface. This is what we call normal force, which the symbol is N. The same happen here. The surface, which is the surface of the Earth in this case, exert the force on this block perpendicular to the surface. We're going to speak about that one in a moment, and this is what we call normal force. Is that force from the surface on the object, and it is perpendicular to the surface. And this is the definition. The normal force is the force or the component of a force. We'll speak about that one later on when we learn about other type of forces. Of a force which is the surface. It's a force which a surface exerts on an object which is in contact with the surface. Of course, if the object is not in contact with the surface cannot exert a force. This is a contact force, and which is perpendicular to the surface. That is the most important part. In actual fact, the word normal means perpendicular in mathematics. This one is perpendicular. That is the word perpendicular, which is normal. So from here, normal is a force. All the forces are vectors, so in a direction. The direction is perpendicular to the surface. Okay, now let's see another scenario. For instance, we have an object that is on an inclined plane, as you can see here. Okay, could be a child sliding down one of those games. All right, now on those boxes, for now, up until now that we learned, there's more forces, but we'll speak about those later on. There are two forces acting. The gravitational force, which is all the time pointing towards the center of the Earth. As you can see here, I'm going to write weight. Okay, you can write gravitational force. I'm not going to write both of them. And normal. Remember, the normal is perpendicular to the surface. So in this case, the surface is in this direction. That is the surface. So what would be a line perpendicular to the surface? Line perpendicular to the surface is a line that have or form a 90-degree angle with the surface. Let's fix that one. It's a little bit not too nice. There we go. So there we go. This one here is 90 degrees. That is why this line is perpendicular. So it must always be perpendicular. So the force is going to be on the object. Right here on this point is fine. I'm going to draw it like that. And that line, let me try to fix it, must be perpendicular to the surface. This is the normal force. I hope it's quite clear. It's very simple. All right, that is the normal force in that case when there is an incline. Now, important, let's say the object is hanging from a rope. Now, in this case, this object is hanging from the rope. In this case, there will be a gravitational force. There's always weight on any object that is near the surface of the earth. So there will be weight. Okay, there will be weight, but they will not be normal. There is not normal. These are the forces. We are not going to speak about those, but there is no normal. Why? Because there is not surface. Because there is not surface. So that object is not on the surface. So this is important. Normal force only will be if there is a surface, or the object is on certain surface like this one there. And guys, this is all. Something important, normal force do not have a formula. Please do not forget this one. The normal force do not have a formula. There is not formula to calculate the normal force. You have to deduct ones, which we eventually are going to learn about that one, okay? But for now, you need to know that the normal force does not have a formula. So maybe we should write it here for normal force. There is no formula. And something important for normal force, the symbol is N. We spoke about that one already. It's a vector quantity, and the SI unit is the Newton. Still Newton with symbol N. Okay, so that is all for the video. I hope you understand. I hope you get the idea, and thank you for watching. If you think it helped, don't forget to subscribe, thumb up. I'll see you next time, Mr. G here.